Hi, in this video we are going to talk about conditional probabilities. Now, conditional probability is more related to events which are dependent on each other. But in order to just also highlight how it will work when we have independent events, we will also kind of touch on how it will slightly change when we talk about independent events. Now, remember, when we talk about dependent events, basically what we are saying is that if we have the knowledge of one event, that will change the probability of the other event. And when we talk about independent events, what we are saying is knowledge of one event will not have any impact on the probability of the other event. So let's go through a particular example and at the same time discuss what do we mean by conditional probability. So here we have two events, event A and event B. Now event A is a particular portfolio X will provide a return. Let's assume these returns are annual returns. So portfolio X will provide an annual return which is greater than 10%. So that's event A. And event B is we have another portfolio called portfolio Y will provide a return which is greater than 10%. So these are two events. Now let's assume that the probability, of event A occurring, so in other words the probability that portfolio X will provide a return greater than 10% in a particular year, let's assume it's 50%. So there's a 50% chance that portfolio X will provide a return greater than 10%. And let's assume that the probability portfolio B will provide a return greater than 10% is 6%. So there's quite a low chance that portfolio Y will provide a return greater than 10% compared to portfolio X. So now when we talk about conditional probabilities, basically what we are saying is, so the word conditional simply means, now if we say for example the probability of a particular event A, probability of A, so in this case portfolio X returning more than 10%, given that event B has already occurred, or given that we already have knowledge of event B. So this notation here, basically what this means is the probability of event A occurring given probability B has already occurred. Now this is what we mean by conditional probability. In other words, we can also read this as probability of A conditional on event B. So that's the conditional probability of A. So when we talk about conditional probability, what we are saying is what's the probability of a particular event given the other event has already happened. In other words, conditioned on the other event. So let's assume that these are dependent events, event A and event B. Now if we want to know the probability of A and B occurring at the same time, so we could start with the probability of A and then we multiply that. Now if we know A has already occurred, that event A has already occurred, then the next probability is probability of B given A has already occurred. So this is the conditional probability. So here what we are saying is, if we want to know the probability of A and B, that's simply the probability of A, and then you multiply that by the probability of B given A has already occurred, because we just put A first here. I mean, you can write the same thing as this, probability of B, and then you multiply this by, if you start with probability of B, then you can say that since probability of B has already happened, then probability of A given B. So here basically what we are saying is that when we want to calculate the probability of event A and B both occurring at the same time, you could start with one of the probabilities. So here first let's keep this to probability of A, and then you multiply that by probability of B given A has already occurred. So let's assume that the probability of A and B occurring, so let's assume that the probability of A and B, so that means both portfolios giving a return more than 10%, there's only 5% chance that could happen. Now let's assume that we already know this one. Let's assume that we already know that probability of A and B is 5%. Now in this case, if we want to know the conditional probability of B given A has already occurred, we simply has to rearrange this formula. So probability of B given A has already occurred is simply probability of A and B, and we divide that by probability of A. So we know that probability of A and B is 5%. Probability of A is 50%. So that will give us 10%. So you could see that if you don't know anything about A, then your probability of B was only 6%. But if A has already occurred, in other words, if A has already taken place, then probability of B slightly increases to 10%. You can see that, you can already see that A and B are dependent events, because the moment you have knowledge that A has already taken place, the probability of B has increased to 10%. So it's not the same. From 6%, it has become 10%. So we know that A and B are dependent events because knowledge of A has some impact on B. Now, if knowledge of A has no impact on B, then we call them independent events. Now remember, if A and B are independent events, what would have happened is that probability of A and B would be probability of A, and then you multiply that by probability of B conditional on A. But you can see that if A and B are independent events, the probability of B, given we already know that A has occurred, is simply probability of B. because knowing whether A has happened or not will have no impact on B. So probability of B given A has already occurred is simply probability of B. So that's what we said. So that will be probability of A multiplied by probability of B if A and B are independent events. That's what we said. The concept of conditional probability is more closely related to dependent events. So the conditional probability, so this formula is a key formula to remember. So when you're calculating conditional probabilities, simply the probability of B conditional on A is simply the probability of A and B, and then you divide it by the probability of A. So remember, conditional probabilities are relevant for dependent events mainly, and it's quite useful to know conditional probabilities. And also, finally, another concept that's closely related to conditional probabilities is unconditional probabilities. So for example, if you want to know the unconditional probability of A, what that means is what's the probability of A occurring without any knowledge of the other event. So that's simply 50%. The same way, the unconditional probability of event B is 6%. In other words, if you don't know any information about A, because here you can see the conditional probability of B is 10%. The unconditional probability of B is 6%. So when we talk about unconditional probability, what we are saying is if we have no information about the other event, then what's the probability? So that's simply 6%. Now, finally, when we talk about conditional probabilities, using decision trees will be quite useful to calculate the probability, which I will show it to you in another video. Thank you very much.